Hello everyone, welcome to Vyas Edification. In this session we are going to discuss NCERT and this is related to class 12th of physics, that is part 1, clear? And in this session we are going to discuss all the solutions of NCERT of chapter number 1, that is electric charges and field. So now dear student, concentrate on a screen, let's start. So now we are going to discuss this question and this is a question number 1.1. In this question it is given to you, what is the force between two small charge sphere having charges of 2 into 10 to the power minus 7 coulomb and 3 into 10 to the power minus 7 coulomb placed 30 centimeter apart in air, clear? So now we are going to solve this question, concentrate on a screen. In this question it is given to you, we have two small charge sphere, very important. So let's suppose I am taking here, let's suppose this is one sphere and this is a small, and let's suppose here we have one more sphere, clear? It is already mentioned in this question we have two small charge sphere. It means we can consider these spheres as a point charge, yes or no? So it is given two small charge sphere having charges. So let's suppose this is Q1 and Q1 equal to 2 into 10 to the power minus 7 coulomb, clear? And it is given we have this is Q2, this is 3 into 10 to the power minus 7 coulomb, clear? They are placed at 30 centimeter apart in air. So we can see distance between these 2 point charges, we have this is 30 centimeter. So R this is equal to 30 centimeter, clear? Our objective in this question is to calculate the force of attraction or it may be repulsion, you have to decide. So electrostatic force, this is acting between the charges, clear? Now you can see on this screen we have here 2 point charges Q1 and Q2 and both are having positive signs. It means we can see here, let's suppose we are taking this sphere as 1 and this one is 2. So definitely I can say here a force that is exerted on 2 by 1, clear? At the similarly we can see force this is exerted on 1 by 2. So we can say both the forces are same in magnitude but opposite in direction. So we can say here definitely we can say if we are having positive charges, here we have a repulsive forces, clear? Now our objective is to calculate magnitude of this electrostatic force, clear? So now how can we calculate? Concentrate. Actually we know here one formula, F this is equal to K Q1 Q2 divided by R square, clear? Now you know what is value of K. K value is given by 1 upon 4 pi epsilon naught and this is equal to what? 9 into 10 to the power 9, clear? And what is unit? We can say this is equal to Newton meter square upon Coulomb square, clear? So now we can put here values. Value of K we have, this is 9 into 10 to the power 9 into value of Q1 and Q2, this is given to you 2 into 10 to the power minus 7 into 3 into 10 to the power minus 7 and it is divided by, it is given value of R 30 centimeter. So first we can convert this centimeter into meter and then we can write like this, clear to everyone? So from here you can calculate value of the electrostatic force, this is acting between two charges. So F this is given by, we can see 9 multiply 2 we have 18, 18 we have this is 54, clear? Multiply 10 to the power 9, 10 to the power minus 7 we have 10 to the power 2 and we can say this is 10 to the power minus 5, clear to everyone? And this is divided by, now we can write like this, this is 30 into 30 into 10 to the power minus 4, clear? Now we can say this is 10 to the power minus 1, clear? So from here we can write like this, electrostatic force this is acting between two charges, this is given by 54 divided by 9, clear? Here we have 100, so we can write like this, this is 100 and this is multiplied with 10 to the power minus 1, clear? So from here you can say, here we can say this is value 6, so F this is equal to 6 into 10 to the power minus 3 Newton, clear? So my dear student, this is very important because you have calculated here magnitude and direction you have already seen logically, clear? So correct answer you can write like this, electrostatic force this is acting 6 into 10 to the power minus 3 Newton, and in the bracket you will write here this is repulsive force. This is the nature of a force. Clear to everyone? So correct answer of this question we have F equal to 6 into 10 to the power minus 3 Newton. This is magnitude of a force. This is acting between the two charges, and this is having repulsive in nature. Clear to everyone? Now dear student, we are going to discuss question number 1.2. In this question it is given to you the electrostatic force on a small sphere of charge 0.4 microcoulomb due to another small sphere of charge minus 0.8 microcoulomb in air. This is 0.2 Newton. Clear? Now we have here two questions. Number one, what is distance between two spheres? Number one objective. Second objective we have, what is the force on the second sphere due to first? Clear? So now we are going to solve this question. So concentrate on a screen. Now listen carefully. Electrostatic force on a small sphere of charge 0.4 microcoulomb due to another sphere of charge minus 0.8 microcoulomb. So let's suppose I am taking here, this is a point charge, and we can say, let's suppose I am taking this is Q2 and this is equal to minus 0.8 microcoulomb. Clear? Now we can say here, let's suppose the distance between these two point charges, I am assuming this is R. Clear? And let's suppose this is Q1. Clear? I don't know what is value of Q1. So it is given to you? Yes, it is given 0.4 microcoulomb. Clear? Okay. And it is also given the electrostatic force this is acting, this is 0.2 Newton. Now you can see, actually we can say here we are having two charges and both are having opposite in nature. One charge is a positive, another one is negative. It means we can say attractive force will act between these two charges. Yes or no? So from here we can say, we can write like this, definitely one force this is acting on 1 by 2. Clear? We can also write like this, force this is acting on 2 by 1. Clear? And we also know this F12 and F21 both are having same in magnitude but opposite in direction. Clear? So we can also write like this, magnitude of F12 this should be equal to, we can say F21. Clear? Or you can write like this, F12 vector this should be equal to minus times of F21. Clear to everyone? Yes or no? Clear? Now listen carefully. First our objective is what? First objective here is to calculate distance between two spheres. So we can write like this, F this is given by K Q1 Q2 divided by R square. Clear? So our objective here is to calculate R. So we can write like this, K Q1 Q2 divided by F. Now value of K we have 9 into 10 to the power 9. So 9 into 10 to the power 9 multiply value of Q1. Value of Q1 is given to you, this is 0.4 microcoulomb. So I can write like this, 0.4 into 10 to the power minus 6 multiply. Clear? Q2. Q2 value we have 0.8. Now listen carefully. Whenever you have already assumed the direction of this force logically, then directly write here only magnitude. Clear? So you can write like this, 0.8 into 10 to the power minus 6. It is divided by, now capital F. Capital F is given to you in this question 0.2 Newton. Clear? So we can also write like this, this is 1 by 5. Clear? Now we can write like this, R square this is given by 5 multiply 9, we can say 9 into 4 by 10 into 8 by 10. Clear? Now we have 10 to the power minus 12, this is 10 to the power 9. So we can say 10 to the power minus 3. Clear to everyone? So from here you can see, this is we can say 20, you can write like this, this is 9 into 4 into, here we have 40, so 40 divided by 10 into 1 by 10 into 10 to the power minus 3. Clear? From here you can see this one and this one cancelled out. Clear? We can say this becomes 10 to the power minus 4. Clear? So I am writing here. Now from here you can see value of R square, this is given by 9 into 4 into 4 into, we can write like this, 10 to the power minus 4. Clear? So if we take here square root, we can write like this, 3 multiply 2 10 to the power minus 2 meter. Clear to everyone? So from here you can say 3 multiplied to 6 and we have 12. So R this is given by 12 into 10 to the power minus 2 meter. Clear? So if we convert into centimeter, you can write like this, this is 12 centimeter. Clear to everyone? Yes or no? So first objective is completed. In question number A, the distance between two spheres, this is given by 12 centimeter. Clear to everyone? Yes or no? Yes. Now if we concentrate on part number B, in part number B, it is given to you what is force on the second sphere due to first. Now you can see force acting on 1 by 2 is having same in magnitude as force acting on 2 by 1. Yes or no? So we can see, you can say actually it forms an action and reaction pair. So from here we can see magnitude of F21, this is force acting on second sphere due to first, it should be equal to, this is F12 and the value is same 0.n Newton. But always write here the nature of this force, we can see this is having attractive. Yes or no? So here we have nature, this is attractive nature. Clear to everyone? So we have the solution F, this is 0.2 Newton and we have distance between two sphere, this is 12 centimeter. So clear to everyone? Now we are going to discuss this question. This is question number 1.3. In this question it is given to you, check that the ratio KE square divided by G ME MP is dimensionless. Okay. Look up at the table of physical constant and determine the value of this ratio. What does this ratio signify? Clear? So first we have to verify, or we can say first we have to prove that this ratio is a dimensionless. Clear? So now concentrate on a screen. Now we can see from here you can write like this, KE square divided by G ME MP. Clear to you? So now from here we can write like this, this is value of K. Value of K we know, this is 9 into 10 to the power 9. Clear? But first we have to derive that this ratio is a dimensionless. So what is unit of K? So first I am writing here value of K also. This is equal to 9 into 10 to the power 9. This is Newton meter square per Coulomb square. Clear? So here we are having unit of K. This is given by Newton meter square divided by Coulomb square. Clear to you? Now here we have E. E is what? Charge of an electron. Clear? So we can write like this, this is given by 1.6 into 10 to the power minus 19 Coulomb. Clear? So we can write like this, 1.6 into 10 to the power minus 19, this is whole square. Clear to everyone? Yes. Now value of capital G, or actually we are writing here units, so we can write like this, this is, we can say Coulomb square. Clear to everyone? Now here it is given value of capital G. So value of capital G, this is given by, we can see we have this value 6.67 into 10 to the power minus 11. Clear? And this is equal to Newton meter square per kilogram square. Clear? So we can write like this, Newton meter square per kilogram square. Yes or no? Now here we are having, this is Me and MP, means mass of an electron and mass of a proton. So we can write like this, mass of an electron, this is given by 9.1 10 to the power minus 31 kg. Clear? Yes or no? And we can also write like this, mass of proton, this is given by 1.67 into 10 to the power minus 27 kg. Definitely you can say mass of proton is greater than mass of electron. Yes or no? So now you can say here we are having units of masses kilogram, so we can write like this. Clear? From here you can say kilogram square is cancelled out, Coulomb square and Coulomb square is cancelled out. Clear? And Newton meter square is also cancelled out. So from here we can say this value is unitless. Clear? This is unitless. So when any value is unitless, definitely we can say this is also dimensionless. Clear? So dimension of this ratio we are getting M0, L0, T0. Clear? So this one we have already proved. Clear? Now important part is here, if we put all the values in this ratio, what value we will get? Clear? So now concentrate. Now actually I am writing here all the values in this expression. Listen carefully. So value of K we have 9 into 10 to the power 9 into charge. charge of an electron, this is given by 1.6 into 10 to the power minus 19 whole square divided by value of capital G. Value of capital G, this is given by, we can say 6.67 into 10 to the power minus 11. Clear? And mass of an electron, this is given by 9.1 into 10 to the power minus 31, and mass of a proton, this is given by, we can write like this, 1.67 into 10 to the power minus 27. Clear? Now you have to solve this ratio, and after that you will find here the value of this ratio. Clear? Now you can say, sir, this is a very large calculation. Yes beta, actually we have here some calculation, but you can easily simplify this calculation. Listen carefully. First write all the values like this, 9 into 1.6 into 1.6. Clear? Here you can say 10 to the power 9, this is 10 to the power minus 38. Clear? So we can write like this, 10 to the power 9, 10 to the power minus 38. Clear? Now also write here, this is what, 6.67 into 9.1 into, we can say 1.67 into, this is minus 11, here we have 31, so I am writing here 10 to the power minus 31 into 27, and here we have minus 11, so we can say this is 10 to the power minus 38. Yes or no? Now you can say this one and this one, this is cancelled out. Clear? And from here you can write like this, 9 into 1.6 into 1.6 divided by, clear, this is 6.67 into 9.1 into 1.67 into, when this will goes to the numerator, this becomes 10 to the power 40. Clear? So now you can say, we can actually do here some approximate calculation. Approximately you can say 9 and 9.1 is almost same, this one and this one approx same. Clear? Now we can say here 1.6 divided by, we have here 1.6 divided by 6.6. So approximately we can say this is 1 by 4. Yes or no? So we can write like this, 1 by 4 into 10 to the power 40. Clear? So approximately we can say we are getting here 2.5 into 10 to the power 39. Clear? This is an approximate result. This is not an actual result. Yes or no? But actually from here you can see that we are getting this ratio this much amount. We are getting this ratio 10 to the power 39. So actually what is the significance of this ratio? So from here you can see, if you concentrate on Ke square upon G ME MP. So Ke square upon, if you write like this, G ME MP upon R square. Clear? From here you can say this is defined as the ratio of electrostatic force to gravitational force. Yes or no? So now you can say, whenever we are getting this ratio, it means electrostatic force is more stronger compared to gravitational force. Clear? And actually we know the gravitational force is the weakest force in nature, and the strongest force we have, this is nuclear force. But if we talk about electrostatic force is much greater than gravitational force. Yes or no? So this is the significance of this ratio, that we are getting more value of attraction, or we can say more value of electrostatic force compared to gravitational force. Clear? So this is all about this question. Clear to everyone? Now dear student, we are going to discuss this question. This is 1.4, and part 1 that is given to you in this question. Explain the meaning of statement electric charges of a body is quantized. Clear? So my dear student, what you understand by the meaning of quantization of an electric charge? So quantization of an electric charge means the total charge that is present on a body is multiple integral of charge, we can say multiple integral of a basic charge, that is charge of an electron. Yes or no? That is known as quantization of an electric charge. Clear? Mathematically we can represent quantization of a charge Q, this should be equal to plus minus Ne. Clear? And here we can write value of N, this is equal to 0, 1, 2, 3 and so on. Always remember, we will not find value of N in fraction. Clear? Because charge always exists multiple integral, always remember. Clear? So we can say value of Q, we can write like this, this is plus minus Ne. Clear to everyone? So this is all about quantization of an electric charge. But what will happen if we talk about the statement number B? Why can one ignore quantization of electric charge when dealing with macroscopic or large scale charges? So actually what will happen, whenever we are dealing with large scale charges, we can say value of n, this becomes very large, clear, and we know the charge of one electron we have 1.6 into 10 to the power minus 19 coulomb, yes or no. So actually in electric charges and field we are dealing with a charge that is point charge, clear, but when we get value of q, this is large, at that time the charge becomes continuous, yes or no, and we can say that quantization of an electric charge we cannot apply on it, clear to everyone. So this is all about this question, clear. Now dear student, we are going to discuss question 1.5. In this question it is given to you, when a glass rod is rubbed with the silk cloth, charges appears on both, fine. A similar phenomena is observed when many other pairs of bodies, clear. Explain how this observation is consistent with law of conservation of charge. Actually law of conservation of charge says what? The total charge that is on an isolated system that always remains constant, clear. So if we consider here number 1, if we consider here, let's suppose this is a glass rod, let's suppose this is glass rod, and here we have, let's suppose this is silk cloth, clear, this is silk cloth, and here we are having glass rod. Initially we can say whenever both are separated or when both are isolated, there is no charge this is present on a glass as well as on a silk cloth. But what will happen when we rub glass rod with a woolen cloth? At that time we can see, after rubbing, I am talking about after rubbing, the glass rod actually acquire here some positive charge, clear, and at that time we can see this silk cloth will gain some negative charge, clear. So actually what will happen, how glass rod is getting positive charge and how this silk cloth is getting negative charge. So I can say some of the electrons that is transferred from glass rod to silk cloth, yes or no. It means we can say some electrons are transferring from glass rod to silk cloth. Then what will happen, there is a deficiency of an electron we will find on this glass rod and we are getting some excess of electron on this silk cloth, yes or no. But what will happen, we can say there is some excess amount of electron this is present on the silk cloth, this is equal to the excess amount, the deficient amount of electron that is present on the glass rod, yes or no. It means we can say if we again consider this as a system and if we consider the total charge that is present on the glass as well as the wool cloth, again it comes out to be 0, yes or no. It means we can say the total charge of an isolated system, this always remains constant. So we can say this follows law of conservation of charges, clear to everyone, yes or no. Now dear student, we are going to discuss this question. This is 1.6. In this question it is given to you 4 point charges QA, QB, QC and QD are located at corners of a square ABCD of side 10 cm. Okay, fine. What is the force that is exerted on 1 microcoulomb placed at the center of a square, clear. So now we are going to solve this question, concentrate on a screen. Now let's suppose first I am drawing here a square. Let's suppose this is square. Yes, so let's suppose this is square and we can say 4 point charges are placed at the corners of a square ABCD. So let's suppose I am saying this is A, B, C and D, clear, and let's suppose we place here 4 point charges. So let's suppose here we have this charge 1, this is 2, this is number 3 and here we are having charge number 4, clear. It is also given value of QA, QB, QC and QD we know. So value of QA, this is given to you in this question 2 microcoulomb, clear. Same here, value of QB, this is given to you minus 5 microcoulomb, okay fine. Value of QC, this is given to you 2 microcoulomb, clear, and value of QD, this is given to you minus 5 microcoulomb, clear to everyone. Now listen carefully, one more point is given to you, side is having 10 centimeter, so this is given to you 10 centimeter, clear to you, okay fine. Now what is force, this is acting on a charge of 1 microcoulomb, this is placed at the center of square. So let's suppose I am placing here a charge, let's suppose this is a charge and this charge is placed at the center of this square, clear, and let's suppose if we find here distance between these two charges. How can we find? Clear? So we can say, let's suppose we can say ABCD and let's suppose this charge is E. Clear? And we know charge, this is also given to you, this is 1 microcoulomb. Clear? Objective is what? Our objective in this question is to calculate the net force this is acting on this charge. Clear? So first I am drawing here the direction of our forces. Clear? So now concentrate. First we can say this A charge, we can say QA, this QA we have positive, and this E, or we can say charge QE, this is 1 microcoulomb. I can write like this, this is 1 microcoulomb, this is also positive. Clear? So from here you can see, we can write the direction of forces like this. We can say here force this is acting on E by A. Clear to you? Yes or no? Now you can also see like this, because this is 2 microcoulomb and this is 1 microcoulomb. Yes, so we can say here this force is acting, this is F, this is acting on E by C. Clear? Now you can also see here we are having negative charge and attractive force that is exerted on the charge E. Yes or no? So we can write like this, force this will act in this direction F, E, and this is with respect to B. Clear? Now we can also write like this, this is also minus, so we can write like this, force is acting in this direction and this is force acting on E with respect to D or by D. Yes or no? So now if we find here magnitude. Clear? So first we will write here magnitude and then let's see in which direction or what is the net force this is acting on a charge E. Clear to everyone? So now concentrate. Now listen. If we write here first FEA, clear? So we can write like this FEA. Let's suppose I am assuming this distance is R, this is R, clear? Every distance we have R, clear? So we can write like this K, clear? Here we can say this is QE, clear? Multiply we have QA and this is divided by R square. Yes or no? Now we can also write like this F. We can say F, this is EC, clear? We can write like this Q, KQE, here we can say QC divided by R square, clear? Now we can write like this F, we can say EB, this should be equal to K, QE, we can say this is QB divided by R square, clear? Here we can write like this F, ED, this should be equal to K, this is QE, this is QD divided by R square. Clear to everyone? Yes or no? So from here you can see in every term we are getting one term common, KQE upon R square. Clear? And here we have this is QA. Yes or no? Then we can write like this here, this is also QE over R square and this is QC. Clear? We can also see like this KQE upon R square and here we are having this is QB. Clear? And this is KQE over R square and this is QD. Now listen carefully. Actually we can put here all the values of KQE upon R square. Clear? But first we will try to analyze that actually what is the forces, what is the magnitude of the different forces this is acting on the charge E. Yes or no? So now you can see if we talk about A, we have charge 2 microcoulomb, so we can write like this K QE upon R square and this is multiply because 2 microcoulomb we have, so 2 into 10 to the power minus 6. Clear? Now you can say here we are talking about FEA. So first we observe what is the force this is acting FEC. Clear? So if we talk about FEC, this is KQE upon R square. Now charge Q at point C, this is given 2 microcoulomb, so we can say 2 into 10 to the power minus 6. Now listen carefully. If we talk about force FEA and FEC, both are having same in magnitude but acting in an opposite direction. So what is net force this is acting on this charge E due to these two forces, that is 0? Yes or no? Because both forces are acting in opposite direction but having same magnitude. You can say like this. Because both are having same magnitude, so net force due to these two charges is 0. Yes or no? Now let's check what is the force this is acting by ED. Clear? So for the ED, we can write like this. This is KQE upon R square, and then we can write this is 5 into 10 to the power minus 6. Direction we have already considered, so no need to write. Clear? Or if you write, then you have to write all the forces in a vector form. Clear? So now we can also write like this. This is KQE upon R square. Now what is charge due to B point? We can say this is minus 5 microcoulomb. So we can say 5 into 10 to the power minus 6. Clear? Now you can clearly see FEB and FED both are having same in magnitude but opposite in direction. Yes or no? So we can say again net forces by these two charges is again 0. Yes or no? So we can say, sir, what is the net force? This is acting on a charge that is placed on the center of this square. We can say net force is 0. Yes or no? So finally I can write like this. Net force, this is acting on a charge that is placed on a center, this is 0. Yes or no? You can also find this same expression in a vector form also. Clear? But it is always better if you consider first the direction logically, and then if you solve for the magnitude and just compare. If you are getting the net force, then you have to apply the law of parallelogram addition, and after that you can get net force. Clear? But here you can see in this condition we are getting equal and opposite forces, so net force we can say this is equal to 0. Clear? So what is the answer of this question? We can say correct answer we have 0 Newton. Clear? Now dear student, we are going to discuss this question 1.7, and this question is related to electric field lines. Now dear student, you know what is electric field lines. Electric field lines are the imaginary curve such that if we draw tangent at any point on this curve, it represents direction of an electric field. Actually we also know there are some properties of electric field lines we have. Number 1, we can say electric field lines always originate from positive charge and it always ends towards the negative charge. Clear? Electric field lines never forms a closed loop. Yes or no? So we can say electric field lines never intersect to each other. Clear? So such that we have some properties of electric field lines. So now we are going to discuss this question, and in this question it is given electric field lines always having continuous curve, or we can say electric field lines never break down, or we can say it never breaks, it never have sudden breaks. So how can we say? Clear? Actually if we talk about magnitude wise electric field, it is given by KQ upon R square. Clear? Now you can say electric field we will find at infinity this is 0. Yes or no? So we can say as we move away from a charge, we can say the charge density or the electric field line density that decreases, but it becomes 0 only at infinity. Yes or no? So we can say electric field lines always having a continuous curve, it does not have any sudden break. Clear to everyone? So this is the answer of question number A. Now if we talk about B, why two field lines never crosses each other at any point? So we can say, let's suppose here we are having here these two electric field lines. Clear? And let's suppose we can say at any intersecting point, let's suppose this is at intersecting point. Clear? So electric field lines never intersect at any point. Why? Because we can say, yes, because we can say at intersecting point, we can say here we are having two direction of an electric field, and that is not possible. Yes or no? So that's why we can say electric field lines never intersect each other. Clear to everyone? So answer is very simple. At intersecting point we have two direction of electric field, and that is not possible. Clear to everyone? So this is all about this question. Now dear student, we are going to discuss question number 1.8. In this question it is given to you 2 point charges QA, that is 3 microcoulomb, and QB minus 3 microcoulomb are placed at 20 centimeter apart in vacuum. This is given to you in a question. Clear? Now we have part number A. What is electric field at the midpoint O on the line AB and joining the two charges? Okay, fine. Second, we have to find if we put a negative test charge of magnitude 1.5 into 10 to the power minus 9 coulomb, or we can say 1.5 nanocoulomb, then what will be the force this is experienced by this test charge? Clear? So this is a question related to electric field. Clear? So we can say whenever we have a charge, and definitely at that time we can say that due to that charge we have an electric field. So when we place another charge in that electric field, it will experience a force. Clear? So in this question we have to find number 1 electric field at the midpoint, that is line joining two charges. Clear? Second, our objective here is to calculate force this is acting on a test charge. Clear? So now we are going to discuss solution, so concentrate on a screen. Listen carefully. In this question it is given to you, we have 2 point charges. So let's suppose I am taking here, let's suppose this is A, this is a point charge, and let's suppose here we have this is point charge B. Clear? And value of QA this is given to you plus 3 microcoulomb, and value of QB this is given to you minus 3 microcoulomb. Clear to you? It is located at 20 centimeter apart in vacuum. So we can see value of R this is given to you 20 centimeter. Clear to everyone? Okay. Now what is electric field at midpoint O of the line joining AB between the two charges? Means let's suppose I am taking here a point, let's suppose this is point O, and this point O is a midpoint between A and B. Clear? Now how we will find here the net electric field? Clear? First we have to find net electric field at O. Clear? So first we find here direction. Actually electric field is a vector quantity, so we can say it will have number 1 magnitude, second one is direction. So first we find here direction logically, or you can also utilize here vector method. Clear? So I am finding here electric field direction first logically, then I will calculate here magnitude. Clear? So now concentrate on a screen. So now we can say electric field due to charge A, this is equal to, we can say because this is positive charge, so we can say electric field direction is always away from a charge. Clear? If we concentrate on a charge B, so definitely we can say electric field is acting in the direction of OB. Clear? Because this is negative charge, electric field direction at any point always towards the charge. Clear? So what is net electric field at point O? So this is given by, we can say this is EA plus EB. Clear to everyone? So now we can calculate here value of EA. How can we calculate? Now we know that EA due to point charge we can write like this, QA over this is we can say R by 2 whole square. Yes or no? So from here you can write like this, value of K we have 9, or directly you can first write like this, this is K, value of QA. Clear? So we can say this is QA, and we can say this is 10 centimeter, so we can say 10 minus 2 whole square. Yes or no? So this is value of EA. Same if we find value of EB, how can we write here? We can write like this, EB, this should be given by K QB divided by, this is 10 into 10 to the power minus 2 whole square. Clear to you? So now we are going to calculate value of electric field. So we can write like this, K value of EA, we can say this is equal to K divided by 10 into 10 to the power minus 2 whole square. Clear? And in the bracket we have QA plus QB. So this is QA plus QB. Clear to everyone? So now we can put here value 9 into 10 to the power 9 divided by, this is 10 to the power minus 1. So we can say this is 10 to the power minus 2 multiply QA plus QB. QA plus QB, QA given to you, this is we can say 3 microcoulomb. Okay, important point, here you cannot write minus because we have already taken here direction logically. So we will put just magnitude here. Clear? So we can say here we have 3 plus 3, this is microcoulomb, so we can write like this, minus 6. Yes or no? So from here we can say this is what, 10 to the power minus 4. So 9 multiply 6, we have here this is 54. So this is 54 multiply 10 to the power 9, and this is 10 to the power minus 4. So we can say 10 to the power 5. Clear? What is unit of electric field? We can say this is Newton per coulomb. Clear? So now we can write like this. Now we can say like this, value of electric field we have at point O, this is given by 5.4 into 10 to the power 6, and this is Newton per coulomb. Clear to everyone? So this is value of net electric field at point O. Clear? Now we are going to discuss part number B. In part number B, it is given if we put a negative test charge of magnitude this one at this point, what is force experienced by test charge? Clear? So now listen carefully. Yes. So if we talk about part B, now we are placing here a negative test charge. Clear? Negative test charge means what? We can say if we are placing here negative test charge, what is direction of force? Clear? Listen carefully. If I again draw here diagram, it will be better. Yes. Listen carefully. So let's suppose here we have a test charge, a point charge. This is A and this is B. Clear? This is given to you in a question QA. This is equal to plus 3 microcoulomb and QB. This is equal to minus 3 microcoulomb. Yes. Now we are placing here a test charge and this is negative test charge. So we can say this is 1.5 into 10 to the power minus 9 coulomb. Clear? Because this is negative test charge, so first we will find here direction of a force. So we can say, we can write like this: force this is exerted by A on O. Clear? This is in this direction because this is positive, this is negative, attractive force will act. Here we have negative test charge, negative charge, and here we are having negative test charge. So it will repel and we will find here this direction FOB like this. Clear? Now if we calculate F net, we can write like this: F net, this is given by, we can say FOA plus, we can say, or we can write like this: F net equal to, we can say, test charge that we are placing at point O and electric field at O. Yes or no? So we can say test charge value is given to you 1.5 into 10 to the power minus 9. So we can write like this: 3.2 into 10 to the power minus 9 multiply value of electric field at O. This is 5.4 into 10 to the power 6. Yes or no? This is given to you. Yes. So from here we can say, we can write like this: this is 10 to the power minus 3. Clear? And we can say this is what? 2.7. Clear? So from here we can write like this: this is what? 8.4, 8.1. 8.1. Clear? 8.1 into 10 to the power minus 3 Newton. Clear? So this is value of force, this is exerted on a test charge. Clear? So this is all about this question. Now dear student, we are going to discuss again question number 1.9. In this question it is given we have a system, and a system consists of two charges. Number one charges we have 2.5 into 10 to the power minus 7, and second we have minus 2.5 into 10 to the power minus 7 coulomb. Clear? It is located at two positions that is given to you in a question. Now what is the total charge and electric dipole moment of a system? So first of all you should know here what is electric dipole. So when two equal and opposite charges are placed a very short distance or very small distance from each other, then we can say this system is known as electric dipole. Clear? So how can we define electric dipole moment? Electric dipole moment is defined as product of charge and the distance between the two charges. Yes or no? So now we are going to apply this concept in this question. So listen. So let's suppose I am taking here, first I am drawing here coordinates. So let's suppose this is x axis, I am taking here this is y axis, and let's suppose this is z axis. Yes or no? And definitely we can say here we have origin, or we can say here we have origin 0, 0, 0. Clear to you? Now in this question it is given two charges are placed at these two positions. Clear? So we can see here we are having a charge, so I am extending like this. We are having charge QB at plus 15 centimeter or z axis. So we can say, let's suppose here this is the position of a charge, and we can say this is B. Clear? Value that is given to you minus 2.5 into 10 to the power minus 7 coulomb. Clear? Okay. And it is at a distance 15 centimeter from origin. Clear to you? Now one more position is given to you. We have a charge A. Clear? Its magnitude is given to you 2.5 into 10 to the power minus 7 coulomb. This is given to you. Clear? And we can see here this is again at a distance 15 centimeter. Clear to you? So now we can see our objective here in this question is to calculate total charge. Clear? So if we consider this dipole as a system, then we can see the total charge that is present. So we can write like this: total charge of the system, this is equal to what? We can write like this. Let's suppose I am taking actually we can write like this: minus 2.5 into 10 to the power minus 7 plus 2.5 into 10 to the power minus 7, and we can say this is 0 coulomb. Clear? Yes or no? So we can say A and B, we have 2 points, and at 2 points we place 2 charges, both are having same magnitude but opposite nature. Clear? So we are having total charge, this is 0 coulomb. Clear? But what about the electric dipole moment? Listen carefully. So we can write like this: electric dipole moment, it is indicated by P. This is a vector quantity, and we can see the charge, and we can write like this: this is 2A vector. 2A vector is what? We can say this is distance between two charges. So you can see both charges should have same magnitude. So magnitude is given to you 2.5 into 10 to the power minus 7. Okay, what is distance between these two charges? We can say 15 plus 15, 30 centimeter. So we can write like this: 30 into 10 to the power minus 2. Clear? From here we can write like this: 25 into 3 into 10 to the power minus 9. Clear? So from here you can write like this: value of electric dipole moment, this is given by, we can write like this: 75 into 10 to the power minus 9. Okay, what is unit? Clear? We can say charge we have coulomb and we have distance, so coulomb meter. Yes or no? Okay. Now you can say, sir, this is a vector quantity and this is just magnitude and the unit. What about the direction? So my dear student, electric dipole moment always have direction from minus q charge to plus q charge. Yes. So from in this diagram we can see what is the direction of electric dipole moment. So we can say here we have negative charge at B, so we can write like this: from B to A. Clear? So if we talk about direction, I can write like this: from B to A. Yes or no? Minus q charge to plus q charge. Clear? So this is all about this question. Clear? Now dear student, we are going to discuss question number 1.10. In this question it is given: an electric dipole with dipole moment is aligned at 30 degree with the direction of uniform electric field of magnitude 5 into 10 to the power 4 Newton per coulomb. Clear? Our objective in this question is to calculate torque acting on a dipole. Clear? So my dear student, you know what is formula of a torque. Oh, okay, you can tell me when the torque will act. So when we can say, when the two forces that is acting along the different line of action, then we can say they produce a torque. Yes. So from here you can see, let's suppose I am taking here, let's suppose we have minus q charge, let's suppose here we have plus q charge. Listen carefully what I am saying to you. Let's suppose electric field is now in this direction, uniform electric field we have. Clear? Now if we talk about the forces this is acting on this charge, we can say F, this is equal to QE. Yes or no? Now we can see here we are having negative charge, so this force will act in the opposite direction. So this F equal to QE but in the opposite direction. Clear? Now we can say both are having different line of action. Clear? So about the center of mass or center of this dipole, we can say this will try to rotate. Clear? So let's suppose I am saying if we talk about direction of electric dipole moment, this is from minus q to plus q charge. Clear? And let's suppose I am taking here this angle theta. Clear? So how can we define value of torque? Torque is given by, this is P cross E. Clear? And we can say this is equal to what? This is PE sine of theta. Clear? So value of electric dipole moment, this is given to you 4 into 10 to the power minus 9 coulomb meter. Clear? So we can write like this: 4 into 10 to the power minus 9 coulomb meter. Value of electric field, this is given 5 into 10 to the power 4. 5 into 10 to the power 4 Newton per coulomb. Clear? And angle between P and E, this is given 30 degree. Clear? Sine 30. Clear? So we can write 20 into 10 to the power minus 5 multiply, this is 1 by 2. Clear? So 10 into 10 to the power minus 5, and we can say we are having value, this is Newton meter, because torque is what, force into perpendicular distance. So we can say this is Newton meter is the unit of torque. Clear? So from here we can say we are getting answer 10 to the power minus 4. Clear to everyone? Clear? So our objective is completed. The torque acting on the dipole is given by 10 to the power minus 4 Newton meter. Clear to everyone? Now dear student, we are going to discuss question number 1.11. A polythene piece rubbed with wool is found to have a negative charge 3 into 10 to the power minus 7 coulomb. Now we have to estimate number of electrons transferred from which to which. Okay, fine. Is there a transfer of mass from wool to polythene? Clear? Now let us try to understand this question. We have here a polythene and we have a wool. Clear? So it is found to have negative charge of 3 into 10 to the power minus 7. So at what we can say we have negative charge on polythene. So we can say on polythene we have negative charge, this is minus 3 into 10 to the power minus 7 coulomb. Clear? So when polythene having a negative charge, we can say here we have excess of electron. Yes or no? Excess of electron. So now we can say electron is transferred from wool to polythene. Clear to you? So we can say from electrons are transferred from wool to, we can say, polythene. Very easy question we have. Clear? Very easy question. Now, is there a transfer of mass from wool to polythene? Yes. So for that one, we have to calculate here number of electrons that is transferred from wool to polythene. Clear? So it is given we have total charge, this is 3 into 10 to the power minus 7 coulomb. So we can write like this, Q equal to Ne. Clear? So if we talk about magnitude, means how many number of electrons that is transferred, we can write like this, Q. We can say this is 3 into 10 to the power minus 7. You can also write here minus. At the time you will write electron charge minus 1.6 into 10 to the power minus 19 coulomb. Clear? So I am writing here directly 1.6 into 10 to the power minus 19. Clear? So from here we can see, and this is given by 3 into 10 to the power minus 7, 1.6 into 10 to the power minus 19. Clear? So from here we can write like this, 30 by 16. Clear? And we can see it is multiplied with 10 to the power, we can see this is 10 to the power 12. Yes or no? So we can see approximately, because we know number of charge that is transferred, we will not find in a fraction. Clear? So from here we can see this is approximately equal to 2 into 10 to the power 12. Clear? It means we can say 2 into 10 to the power 12 number of electron is transferred from wool to polythene. Clear? Now what is our objective in the second part? Is there any mass transfer? Yes, because an electron is having a mass 9.1 into 10 to the power minus 31 kg. So we can say what is total mass transferred? Total mass transferred. So total mass transferred, we can see this is equal to 2 into 10 to the power 12. Clear? This is number of electron. Now mass of one electron, we can say 9.1 into 10 to the power minus 31 kg. Clear? So we can say total mass is transferred 18.2 into 10 to the power, we can say minus 19. Yes or no? Or you can say 1.82 into 10 to the power minus 18 kilogram. So although this mass is very less, but because electrons are transferring from wool to polythene, it means definitely there should be some mass transfer also. Yes or no? So this is all about this question. Now dear student, we are going to discuss this question. This question is having two parts, A and B. In first part it is given two insulated charged copper sphere A and B have their centers separated by a distance of 50 centimeter. Fine. What is mutual force of electrostatic repulsion if charge on each sphere is given to you? Clear? So now we can see actually here we have two spheres. So this is what, let's suppose this is sphere number A. Let's suppose here we have another sphere. Clear? Distance between two sphere, it is given to you 50 centimeter. So R, this is equal to 50 centimeter. Charge is given to you QA equal to QB. 6.5 into 10 to the power minus 7 coulomb. Clear? Our objective here to find electrostatic repulsion. This is acting between two charges. So F, we can write like this, K Q1 Q2 divided by R square. Clear? F, value of K we know, 9 into 10 to the power 9 into, we can say 6.5 into 6.5 into 10 to the power minus 14 divided by value of R, this is 50 centimeters, so we can say 0.50, this is whole square. Clear? So now if we calculate here value of F, how can we calculate? We can write like this, 9 into 6.5, I am writing 13 by 2. So 13 by 2 into, we can say 13 by 2 multiply 9, this is minus 14. So 10 to the power minus 6, 10 to the power minus 5. Clear? This is 10 to the power minus 5. Clear? And here we have 0.50, it means 1 by 2, it becomes 1 by 4, 4 goes to numerator, this one. So 4 and this one cancelled out. Clear? So from here we can say 9 multiply 169 into 10 to the power minus 5. Clear? So from here we can write like this, we can calculate like this, 170 minus 1 into 10 to the power minus 5. Clear? So now we can write like this, yes. So value of F, this is given by 0, 3, we have 6, this is 1530 minus 9 and multiply 10 to the power minus 5. Clear? So we can write like this, 1521 into 10 to the power minus 5 Newton. Yes or no? Now we can also write like this, this is 1.52 into 10 to the power minus 2 Newton. Clear? Or approximately we can say 1.5 into 10 to the power minus 2 Newton. Clear? So this is electrostatic repulsive force acting between two charges. Clear? Now next in this question it is given to you, part B. What is force of repulsion if sphere charge is doubled and distance between two sphere it becomes half? Clear? So we can say F dash, this is given by K, we have 2Q, we have 2Q and it is divided by R by 2 whole square. Clear? So we can say this is equal to 4 KQ square divided by, this is R square by 4. Clear? So we can say this is 16 KQ square divided by R square. Clear? Okay. So KQ square upon R square, this is electrostatic repulsive force and this is equal to 1.5 into 10 to the power minus 2 Newton. Clear? So now we can write like this, F dash, F dash, this is given by 16 into KQ square upon R square, 1.5 into 10 to the power minus 2. Clear? So we can say this is equal to 16 multiply, we can say 3 by 2. So we can say 24. 24 into 10 to the power minus 2, or we can say this is 0.24 Newton. Yes or no? So this is repulsive force acting between two charge when charge on each sphere becomes double and distance between them becomes half. Clear to everyone? So this is all about this question. Now distant we are going to solve this question. Question number 1.13. In this question it is given to you, suppose the sphere A and B that is already we solved in this question, clear, have identical sizes. Let's suppose we have two sphere and both our sphere are having identical sizes. This is given to you. A third sphere of the same size but uncharged has brought in a contact with the first, then brought in contact with second. Okay. Finally removed from both of them. What is new force of repulsion between A and B? Clear? So let us try to understand what is situation. Clear? Listen carefully. Let's suppose initially, let's suppose I am saying initially we have this is A, let's suppose this is B, clear, this is B and both are having charge Q, clear, both are having charge Q and it is given value of charge Q, value of charge Q, this is given to you, yes, value of charge Q is given 6.5 into 10 to the power minus 7 coulomb, clear, this is given, clear. So I am writing here value of Q 6.5 into 10 to the power minus 7 coulomb, clear. Now what happened? Now let's suppose we are bringing another sphere having uncharged, but having same size. Clear? Let's suppose here we have this sphere number C and this is uncharged. Now in this question it is given a third sphere first brought in contact with the first. Clear? So let's suppose it comes into contact with this A. Clear? So when both spheres are having identical size, then we can say after touching their charge is equally distributed on each sphere. Clear? So we can see whenever we are talking about A and C, if I draw like this, let's suppose this is A. Clear? Let's suppose now it comes into contact with the C. Clear? So it is having Q, this is 0, finally it becomes like this. We have A having charge Q by 2, clear, and half of charge it transferred to C like this. Yes or no? Now it is given in the question, then it brought in contact with second, means now here we have B and B is having charge Q. Now this C comes into contact with B, clear, and it is given here the charge is Q by 2. Now again charges is equally distributed on both spheres. So we can write like this. Now we have B, this is C, clear. Now we can say average charge we will take Q plus Q by 2. Here we have 2. So Q plus Q by 2, this is 3Q by 2 divided by 2. So we can say here we have charge 3Q by 4 and this is also 3Q by 4, clear. So this is a charge. Now question is asking to you, finally remove from bottom, what is new force of repulsion between A and B? Now you can see in A we have force, this is Q by 2, and B we have actually we have charge at A Q by 2 and at B we have 3Q by 4. So now we have to find new force of repulsion, clear. So now we can write like this. Listen carefully. We can write like this, new force of repulsion K Q. Q is given, this is Q by 2 and this is 3Q by 4 and divided by we can say R square, clear. So R is given 50 centimeter, clear. So 50 into 10 to the power minus 2 whole square, clear to you. So now from here you can see all the situation is same as previous question, but charge distribution is different, clear. So we can write like this, K, we can write like this, KQ square divided by this is 50 centimeter, yes or no. So we can say actually we can write like this, this is R square. If we write in terms of variable we can write like this, clear. This is R square, clear. So KQ square divided by R square and multiplied with, we can say 3 multiplied with 8, so 3 by 8. Now KQ square upon R square, this is force of repulsion that we find between A and B initially, clear. So we know if we utilize that force, then we know that value 1.5 into 10 to the power minus 2 Newton. This value we utilize from previous question, clear. So we can write like this, 4.5 divided by 8 into 10 to the power minus 2 Newton, clear. So from here we can say this is 0.5, clear. We have 5 left, so 0.56 into 10 to the power minus 2 Newton, clear. So this is what we can say, this is new force of repulsion between A and B, clear to everyone, yes or no. So this is correct answer. Now dear student, we are going to discuss question number 1.14. In this figure it is given 3 charges is actually passing through an electric field and all particles are having different deflections, clear. Now we have to find that according to 3 path, give me that what is the sign of a charge of a particle, clear. So now you can see from this diagram, here we have a positive plate, this is negative plate. So if we discuss here direction of electric field, definitely I can say direction is from positive plate to negative plate, yes or no. So we can say here we are having uniform electric field, clear. Now important task we have, here we are having 3 particles, clear. Now let's suppose if I place any charge particle, let's suppose I place any charge particle Q here. Listen carefully. So when any charge particle is placed in an electric field, we can say at electric force this is acting on this charged particle. If this charge is a positive, it will act in the same direction of an electric field. If charge is negative, force will act in opposite direction of an electric field. Yes or no? So we can say here, if I consider this is a charge q. If this charge q is positive, I will say the particle will move along the path 3. Yes or no? Because it is having some initial velocity that is in this direction, and definitely a force will act in this direction and particle will move through path number 3. So we can say from path number 3, we can say positive charge particle, it will going like this, positive charge, and we can say particle 1 and 2 is negative charge, negative charge particle, negative charge particle. Clear to you? So 1 and 2 is negative charge particle and 3 is positive charge particle. Clear? Now this is number 1 question, that is the sign of 3 charges. Which particle has highest charge to mass ratio? Clear? Now listen carefully. If I say to you, let's suppose a particle is going from here, and let's suppose if I consider this particle, it is going like this and it is going like this. Yes or no? So let's suppose from here to here, if we consider at this point, and let's suppose this is point, and we can say here, let's suppose this vertical distance we have h. Clear? So whenever we are having positive charge, we can say, we can write like this, F equal to ma. Clear? So when this particle is going through the path number 3, we can say this force, this should be equal to QE. So acceleration, this is given by QE by m. Now we can say charge of a particle fixed, electric field value is fixed, mass is also fixed. It means we can say acceleration of a particle is constant. So we can apply equation of motion in vertical direction. So we can say Sy, this should be equal to Uyt plus half of Ayt square. Clear? Now if I am taking this as my reference, so I can write like this, this is minus h, initial velocity in vertical direction, this is 0 plus 1 by 2, we can say Ay we can say this is minus QE by m, and we can say this is t square. Clear? Our objective in this question is what? Find which particle has highest charge to mass ratio. So from here you can see h, this should be equal to 1 by 2 QE by m, and this is t square. Clear? So from here we can say h is directly proportional to q by m. So definitely we can say the more deflection in y direction, if we find, definitely we can say that charge particle is having maximum q by m ratio. Yes or no? So from here you can say the maximum deflection that we are observing here for the particle number 3. Clear? So we can say particle number 3 is having maximum E by, or we can say q by m ratio. Clear to you? So I think this question is clear to you. Number 1, sign of 3 charges, 1 and 2 negative and 3 is positive. Okay. Highest charge to mass ratio we have particle number 3. Particle number 3 is having highest charge to mass ratio. Clear to everyone? Yes or no? So this is all about this question. Now we are going to solve this question number 1.15. In this question it is given, consider a uniform electric field E 3 into 10 to the power 3 I cap, means the electric field is acting in positive x direction. What is flux of this field through a square of side 10 centimeter, which plane is parallel to YZ plane. Clear? So now concentrate on a screen. If we talk about part number A, let's suppose I am assuming this is x axis. Clear? Here we have y axis and this is z axis. Clear to you? Yes or no? Now consider a uniform electric field. So uniform electric field is given to you in x direction, so in this direction. Clear? We have a square plate, or we can say square plane of having side parallel to YZ plane. Clear? So I am drawing here like this, this one. Clear to you? So we can say this plane lie in YZ plane and electric field is acting in positive x direction. So we can say if this is an area vector, so direction of this area vector is also like this. that is perpendicular to this plane. So our objective in this question is to calculate flux. Now what is electric flux? Electric flux is the number of field lines that is passes through our area. Yes or no? And mathematically we can write like this, phi, this is given by E dot dA. Yes or no? And we can say this is actually dot product between electric field and area vector. Clear? Now in this situation, in part number A, we can see electric field and area vector both are in same direction. So we can write like this, 3 into 10 to the power 3, this is I cap, here we have dot and area vector. Area vector is given to you, this is 10 centimeter and this one is all 10 centimeter. So we can write like this, 10 into 10, this is 10 to the power minus 4 and this is also in I cap. Clear? So we can write like this, 3000 multiply, we can say 10 to the power minus 2 and this is I dot I. Okay, I dot I, it is equal to what? 1. So we can write like this, this is 30, yes or no? This is 30 and we can write like this, Newton per coulomb and meter square. So this is value of flux, this is passes through a plane that is parallel to YZ, yes or no? Now in the second it is given, find the flux through the same square if its normal is making 60 degree with x axis. Clear? So now we can see situation now changes. Now if we concentrate on part number B, situation is like this. Let's suppose this is x axis, this is y axis and this is z axis. Clear? Or you can also write like this. Let's suppose here we are having plane like this, Let's suppose this is a plane, clear, and area vector of this plane in this direction. Clear? We can see x axis is in this direction. So this is direction of electric field, this is direction of area vector, and angle between electric field and area vector, this is given to you 60 degree. Clear? So how can we calculate flux? This is given by EA cos of theta. Clear? So electric field is given to you 3 into 10 to the power 3. Area vector 10 centimeter side is given, so 10 into 10 into 10 to the power minus 4. Yes or no? And cos theta. Theta is angle between area vector and electric field, so this is cos of 60. Clear? So from here we can write like this one and we can say this one cancelled out. So 30 into 1 by 2, this is 15. We can say because this is flux, so Newton per coulomb meter square. Yes or no? So this is the answer of this question. Now dear student, we are going to discuss question number 1.16. In this question it is given to you, what is the net flux of uniform electric field of example 1.15 through a cube of side 20 centimeter oriented so that its faces are parallel to coordinate planes. Clear? So now the situation is given like this. Let's suppose we are having a cube. Listen carefully what I am saying to you. Let's suppose this is cube. Clear? And its side is actually parallel to coordinate axis. Clear? I am assuming this direction as x axis, this one is at y direction and this one is z direction. Clear? Now we can see, if we consider here about total number of faces. So total number of faces we have here 1, 2, 3, 4, 5, that is backward, and 6, this is front. Clear? Now we can say in this question electric field is given to us in positive x direction and value is given to you 3000 I cap. Yes or no? And value is given in Newton per coulomb. Clear? Now so we can see we always find flux through a surface that is perpendicular to electric field lines, or we can say whenever angle between area vector and electric field this is equal to 0, we always find flux. And if we discuss about 1, 3, 5 and 6, area vector is perpendicular to electric field lines. Clear? We can see like this. Now if we talk about this one, we can say this is E, and in this direction we have area vector E2, in this direction we have E, and we can say in this direction we are having area, this is A1. Clear? this is A4. We can see area vector is perpendicular to E1, yes or no? Here we can see area vector is A3, this is perpendicular to this one, clear? Same we can say for 5 and 6, clear? So finally we can say our objective here is to calculate phi net. So we can say phi net, this is given by number 1, the flux that is coming. So inward flux we have this one, yes or no? Or we can, you can write like this, we can say this is equal to phi 2 plus phi 4. Because electric flux is a scalar quantity, we can directly add it. So phi 2 equal to, we can say this is E dot, this is A2, clear, plus phi 4. Phi 4 is given to you, we can say E dot, this is A4. Now angle between electric field and area vector 0, so E A2 cos of 0 plus electric field and area vector is opposite, means E A4 cos of 180. Now we know cos 180, this is equal to minus 1, clear? So we can write like this, E A2 minus E A4, clear? Now we can see area of fourth plane or area of second plane, this is same. So we can write like this, this is equal to 0, clear? Unit we have Newton per Coulomb meter square, clear? So net flux, this is passing through this surface, we have 0 Newton meter square per Coulomb, clear? So net flux through this phase, this is 0. So correct answer we have 0. Now we are going to discuss question number 1.17. Careful measurement of the electric field at the surface of black box indicates that the net outward flux through the surface of box is 8 into 10 to the power 3 Newton meter square per Coulomb. This is given to you. What is net charge inside the box? Now listen carefully. Let's suppose here we are having a box. Let's suppose I am drawing box like this. Let's suppose this is a black box. This one, clear? Now in this question it is given phi net is given to you. It means net flux, net outward flux, that is 8 into 10 to the power 3 Newton meter square per Coulomb. So phi net, this is equal to 8 into 10 to the power 3, 8 into 10 to the power 3 Newton meter square per Coulomb, clear? Our objective here is to calculate net charge. Now listen carefully. Let's suppose we place here some charge, and let's suppose we are having value of net charge, this is Q net, clear? Definitely inside this box we have a charge. Through this charge electric field lines that is going outside. So we can say here definitely we will find net electric flux that is passing through this box, or we can say net outward flux we will find, clear? So we can say phi net, this is given by Q net divided by epsilon naught, clear? So we can say Q net, this is given by net outward flux, or we can say this is phi naught, clear? Our objective in this question is to calculate net charge. So we can write like this, Q net equal to phi into epsilon naught. So value of flux, electric flux, this is given 8 into 10 to the power 3 multiplied. How we will find epsilon naught? Actually you know epsilon naught value we have, this is 8.85 into 10 to the power minus 12 Coulomb square upon Newton meter square, clear? Or you can also write like this, 1 upon 4 pi epsilon naught, this should be equal to 9 into 10 to the power 9. So how can we calculate value of epsilon naught? Value of epsilon naught we can write like this, 1 upon 4 pi into 9 into 10 to the power 9, clear? Same value you will get 8.85 into 10 to the power minus 12, clear? So if you multiply, you can write like this, 8 into 8.85 into 10 to the power minus 9, clear? And if you multiply, we can say we have 40, we have 4, 64, we have 8, we have 6. So we can say this is 70, yes or no? And we can write like this, 70.8 into 10 to the power minus 9, clear? So from here we can say this is 7.08 into 10 to the power minus 8 Coulomb, clear? So this is net charge present inside this black box, clear to everyone? Now second part is given to you, if net outer flux through the surface becomes 0. Okay, fine. It means net outward flux, if we have 0, then can we say is there is no charge, this is present in a black box? Wrong. Clear? Because here we are writing net charge. Clear? Net charge means there is a possibility here we are having charge q, minus q, plus q, minus q, and net charge this becomes 0. Yes or no? So this statement is actually wrong. Clear? So if net flux is 0, it means we cannot say definitely there is no charge present in a black box. Clear? It may be possibility the net charge this is present on this black box, it becomes 0. Yes or no? So this is all about this question.